The next speaker is going to be Mr. Carven Scott, Director of the NOAA National Weather Service, Alaska Region. He's going to talk to us about the Weather Service in Alaska strategic planning to meet emerging Arctic maritime operational challenges.
Okay, so this is that's not going to work for. Use the up and down keys. No, it's not going to work. Okay. Okay, good morning. My name is Carven Scott. I'm the Regional Director for the National Weather Service, Alaska Region. Been up in Alaska 27 and a half years. As I tell my family, I'm a Texan by birth, but an Alaskan by choice. And I do want to say, Pablo and Ruth, I don't appreciate you holding it here in July. I live in Girdwood, Alaska, the northernmost extent of the rainforest in North America, and I came down here for this sort of weather, and this is killing me, even though being a Texan. So, okay, hopefully this will work. Up arrow? Okay, thank you, Pablo. See, is it the upper arrow? Oh, this does work. Oh, okay, magic. Okay. And I do want to really thank my preceding speakers, and you should thank them also because, like I said, I was working from a new slide deck. I had about 80 slides, so I thank Molly and David Jackson over here, and Pablo, and Commander Lane, and I think Molly. I don't know if Molly's still here. And I'll say the folks that preceded me took my 80 slides down to about 16. So it's made my new slide deck a little bit more manageable. So if I stumble a little bit, it won't be quite as bad as it would have been prior to. So what I'm going to talk about today, again, the thanks, talk a little bit about the National Weather Service. For those of you that don't know what we do and what we're responsible for, our mission, of course, is protection of life and property, enhancement of the national commerce. Talk a little bit about operational challenges we have in Alaska. And also we're going to talk a little bit about gaps and impacts. In fact, Molly talked a little bit about it, as well as some other folks, about observational gaps we have in the Arctic in general, but in Alaska in particular. Talk about stories, because really it's all about stories, and it's personal stories. And so I'm going to talk about things that have happened as a sort of kind of examples of the things that we deal with that impact Alaskans. And then finally, I'm going to talk a little bit about what we're doing in the National Weather Service to transform our operations. It's called Evolve NWS, to take us from a product-centric, as we say, throwing products over the transom, expecting our customers and stakeholders to be able to use that information, to more embedding with our stakeholders and our customers, to understand their needs and requirements, and then to create services that are tailored for their what they need, whether it's the U.S. Coast Guard, state of Alaska, in order to do, as they're doing their risk management, and also making decisions for whatever part of whatever industry they're in. So, and one of the things that at the very end, what we're doing up there is we have developed, and I'll talk a little bit about it, our Arctic Test Bed and Proving Ground, and also as we transform our operations in Alaska, we're creating what we call the Alaska Environmental Science and Service Integration Center. So I'm putting up, I guess the next slide is really the kind of an obligatory thing that what the Weather Service does. This is sort of a short summary. We have everything that the lower 40, you guys, well, not in the lower 48, or we, as we refer to you from Alaska, those of you that are outside, and if you've been in Alaska, you know exactly what I'm referring to. And if you notice here, we actually have, space weather is an issue. Even though we're not the Space Weather Authority, space weather exacerbates everything that goes wrong in the Arctic because of obviously the nearness of the magnetic pole. And so that if we have, for instance, if there's a search and rescue operation with the Coast Guard, who we support almost on a daily basis, is that with a space weather event like a coronal mass ejection that would cause degradation of HF communication or what they call ionospheric scintillation, which would impact the GPS lock. If you can imagine a SAR exercise and then where you can't communicate and you don't know where you're at, it just exacerbates all the other things that go on in a, I'll say, in a potential, turns a bad situation into a tragedy. Okay, and so as you can see here, again, some of this has already been alluded to, that we have really a dearth of surface and maritime observational capability. And that includes wave buoys in the maritime as well as ice buoys. We've got only 7 network radars in the state of Alaska. We have upper air. We've only got 13 upper air soundings across the state of Alaska. We have a minimal capability for lightning detection. In coastal water level gauges, we've got, I think Molly talked about yesterday, we've got 3 inland stations across the state of Alaska. Stream gauges, and those of you that live in and around here in the DC area, there are more stream gauges in the state of Maryland than there are in the state of Alaska. Climate reference networks. We have somewhere around 25, 26 of them, as I call. We've got so in climate, being able to actually have that capability to measure climate change is impacted. Snow depth precipitation gauges, the ability to measure volcanic ash. We have, as you probably know, we've got about 68 active volcanoes in Alaska that have been in the historical record. We've got 3 going on right now that have been the gifts that keep on giving, and impacting aviation as well as maritime transportation and the Aleutian chain. So what this does is it impacts those of us that are involved in environmental monitoring and forecasting. It impacts our situational awareness. And probably more importantly, for this information is assimilated into models, wave models, ocean models, coastal circulation models, atmospheric models. And if with a lack of data, which then actually negatively impacts the performance of these models, environmental models, and then which then causes our forecast to be less accurate than they are down in the lower 48. And then because of the lack of information to validate the models, then that impacts our ability to what we call bias correct, meaning that to look at the biases in the model and then provide some sort of automatic correction. So all this impacts our ability to forecast weather, waves, water again, in the high latitudes. And of course, if you look upstream, the Chukchi Sea, the Beaufort, and certainly out to the west in Siberia, there's a lack of weather and environmental information. And so this is another one fun slide I love to put up. This is what I call the obligatory Alaska, how much bigger our dad, how much tougher our dad is than your dad, and how hard it is. We've got 3 forecast offices in the state of Alaska that covers the equivalent here in the lower 48 of 68 forecast offices. And as I tell my family, I said, if you down in Texas, that if you don't quit giving me a hard time, that we're going to actually cut Alaska in half and make Texas the 3rd largest state. And so the interesting thing is that as I quite often refer, we in Alaska are latitudinally and longitudinally challenged, and with that we tend to be in the storm track in Alaska for a good portion of the year, 9 months out of the year, and sometimes 12 months out of the year, which then, as you say, right now that down in the lower 48, quite often there's not a lot going on, afternoon thunderstorms, sometimes a tropical here as you get into August and September. But literally, we're in the storm track for most of the year, which, I think we average about 12 hurricane force sustained wind storm systems per year that impact our AOR, except we don't name ours. And so so going on here, again, we want to tell some stories. And the first one up here, this is the sailing vessel, Alton, I guess it was the Alton Girl 2014. An individual thought it was a great idea to put a sailboat up there, and he got locked into the ice. And again, I think Pablo, you were on board? You weren't on board then? So I was not the guy. You weren't the guy, okay. Anyways, so this is cut into the scientific. This is the Healy had to go out and help pull this guy out, basically. I think we've already previous speaker referenced this event. So the Coast Guard called the Fairbanks Forecast Office and our ICE program to help find the way, we're looking at the weather, which was the best way to help navigate this guy out of the ice. And so this is becoming more. We've had actually several of these events over the last 3 or 4 years. The lady from Kotzebue up here. This is what we call an ice shove or an EVU. This was in May of 2011 in Kotzebue. And what happened is the fast ice starts to break. Then we had a moderate wind event onshore, about 20 knots, and about I guess it was about 6-foot seas, as I recall, that pushed this shore fast ice up into this structure. This is not where you want to live right now, I suspect. But believe it or not, the winds kind of laid down, and there was a couple of D9 cats that actually this structure actually survived. But we're starting to see more and more of these events. Barrow gets them. Gets a couple of these events every year. 2011, I had some pictures. I pulled those out. But 2011, 2013, these storms, what makes where the climate and the sea ice issues that we have seen, and again, in my 27 years in Alaska, the shore fast ice and the pack ice is forming later, on the order of 2 to 3 weeks on the west coast of Alaska. So our storm season the storms become really intense in that late October and November time frame. It makes our coastal areas much more vulnerable to these sorts of events, because that shore fast ice, once it locks in, it tends to protect the coastal communities from coastal erosion, from run-up, and for storm surge. And so 2011 and 2013 were particularly bad years, and this was at Kotlik. And this was actually working with the city of Golovin, and where they actually put some berms up here to help protect Golovin. And again, this is what happens. Again, this is Shishmaref. I think probably a lot of folks have seen this picture before, where the vulnerability due to these storms, due to the lack of shore fast ice or stability of shore fast ice coming in later, has just exacerbated the coastal erosion. And here we see a home obviously falling off and into the shore area. So another story, sea ice impacts to aviation. Most of what we've talked about has been discussed here in this symposium has been what happens with the lack of sea ice in the summertime, or as I referred to on the previous slide, the lack of shore fast ice in the fall. And that makes our communities vulnerable. But now we're seeing things over the last 5 to 6 years that is having impacts that in the wintertime. This was actually in March of 2016, where we had a polynya formed just off the coast, as you can see here, just off the coast of in the Beaufort Sea between Kaktovik and Prudhoe. And what this becomes, this open area, this polynya, this is where the shore fast ice pulls away. This easterly flow, as it comes across, picks up the water, picks up the heat. It makes the atmosphere unstable, and you get these tracts of stratus and supercool water will come across in this polynya area and will then impact visibility and cause snow to form or to fall all along the north slope for days at a time. Now, what makes this really bad from an aviator's perspective, I'm not sure how many aviators we have here, obviously with supercool water, that's what leads to icing. And then if you're using a rotary aircraft, the rotary aircraft helicopter is even much more vulnerable to aircraft icing. So these are things that we're starting to think about from a service delivery with the Weather Service, is the impact of potentially more open ice that could impact aviators and potential search and rescue, or for that matter, just general aviation. This is actually another similar sort of event. This actually occurred on St. Lawrence Island in the northern Bering Sea and on Savunga. As you can see here in this satellite image, and I'm looking back, Eric Stevens, thank you very much, from GINA. GINA, we couldn't live without GINA and their ability to create a lot of our polar orbiting imagery of the various types that we have. And this is courtesy of, this image here is courtesy of GINA out of the University of Alaska Fairbanks. As you can see, Savunga here, St. Lawrence Island, Bering Strait. we had a pattern shift so that the winds became more southerly, pushed the pack ice away from St. Lawrence Island, so that we had a gap of about 40 miles. So then the pattern shifts again. We get a strong northerly flow, very dry, cold air near zero. And so then what you have is we have icing develops. So we get freezing spray as the winds generate the waves. And it started freezing up. As you can see, this is from the Alaska Village Electric Cooperative at Savunga. The freezing spray got on the insulators, and in essence, the line slapped because of the winds that basically froze the town up and then killed the electricity. And it was literally almost between one-third and one-half of the village lost electricity. Pipes froze. Basically, the village had to then go down to the school, which had the only generator, and they were isolated basically for 6 to 7 days because of the inability of the state of Alaska, who is the first responder. We don't have counties in Alaska. We have boroughs, and we have a lot of unincorporated areas, and the state of Alaska becomes the first responder through the Air National Guard. Couldn't get in for 6 to 7 days. And this actually, we had a similar event this past winter, where, and we saw the pattern shift, and we actually started working with the state of Alaska and also with some of the coastal villages, including Savunga, to help them prepare ahead of time. And gosh, it was about 10 days. We put a 10-day forecast out, and so they were prepared ahead of time. And so this is there's some reference to what a lot of the scientific entities and service delivery entities working with the indigenous populations. As everybody probably knows, state of Alaska, there's a lot of subsistence hunting goes on in the villages. Excuse me. Especially in the coastal communities. One of the things that we developed probably about 6 to 7 years ago in working with the ARCUS and with the University of Alaska Fairbanks, and then also the Eskimo Walrus Commission out of Kotzebue. And we developed a product called Sea Ice for Walrus Outlook. And basically the purpose here is, again, is part of our mission, is protection of life and property, to help with the subsistence hunters to ensure that they have the situational awareness they need in order to do the subsistence hunting in a safe way. And also those that might be first responders if there is an issue, which I actually have an example here I'll show. There was a subsistence hunters in Shishmaref, I think this was June 8th, I believe it was. Yeah, June 8th, where I think we actually referred to it earlier on Monday, I believe it was, or Tuesday, that they went out in the afternoon, glassy seas came up, they got into the broken ice, and actually 15-foot waves, and they got stranded and had to have worked with the National Weather Service Ice Program, Fairbanks Forecast Office, to actually help them get out. The Coast Guard was the first responder on scene here. And so this is, again, this particular product, became part of as part of our service delivery, as we say, for subsistence, the hunter in our coastal villages. And this is probably, people talk about what keeps you up at night. And as the responsible agent is for the National Weather Service mission in the state of Alaska, having been up there 27 years and having forecast in the marine area for, I'll say 20 of those years, it's the freezing spray issue within our marine forecast mission. And for those of you that are not meteorologists and don't really, it's pretty simple that if the water's cold enough and with cold air coming off of the ice edge, as you can see this false color image, again, thanks Eric. This is a false color off of our SMPP satellite, and you can kind of see the ice edge here, and you can actually see the trailers coming off of the ice. And this is actually the Pribilof area. This is St. George, St. Paul Island, and the East Central Bering. And there a ship which was the destination, the marine vessel destination. 2 nautical miles off of St. George. I think it was 5 souls on board. Went down in probably in less than 90 seconds. and they found some debris from the ship, but didn't find the vessel, did not find any of the souls on board. And this is an example of the several things that we have every winter where freezing spray impacts the safety of our mariners out there. So I won't spend too much time on this particular slide. We've seen this, the receding ice in the wintertime, things that we are doing. We're supporting. We supported BOEM in the drilling operations, 2012, 2015. We've done a number of bridge visits and working with the Coast Guard in support of Crystal Serenity as the emerging marine transportation and the recreational, what do you want to call it, cruise industry. And we continue, again, our idea is not to work directly with the cruise ship lines, but to work with the Coast Guard as the primary law enforcement and search and rescue agent for within Alaska waters. And so a lot of our partners here that we're working with, not the least of which is U.S. Coast Guard, and as you're going to see, Polar Knowledge Canada, and I've got 2 more slides, Pablo. What we're doing actually going forward to transform our operations is, as I talked about, we call it Evolve NWS, and we call it Evolve NWS Alaska. And as you say, deepen service to our core partners, enhance science and technology capabilities, and engage strategically to grow the broader enterprise. And with this, the purpose is we need to get into the decision-making matrix of our core partners and stakeholders to do what we call impact decision support services. And again, it's all about building coastal resiliency so that they're ready, responsive, and resilient. The first thing that we've done is that we're developing the Arctic test bed where we can do R2O to take the good research that's going on, deliver it into operations to improve our mission ability to execute the mission. We've got a number of ongoing initial projects. And then finally, we're developing what we call our Alaska Environmental Science and Service Integration Center. And as you can see, what we're trying to do here to focus not just the Weather Service, but interagency support to provide integrated, cross-cutting sort of service delivery. And so this is what heavy snow looks like in Girdwood, Alaska. So.
Thank you, Carven.